Hi everyone, my name is Tao Tang from Federation University Australia. This is my second year. So today I will give a presentation about my research and I think at the beginning stage, so entitled Data Efficient Graph Learning Meets Ethical Challenges. And at the beginning, I would like to thank the Federation University Australia HDR funding and also the SMS Skill Student Travel Grant. Thanks for their support. And as we can observe, recommender systems are everywhere, and from the search engines, the music platform, and also some online stores. So there is a term, what are responsible recommender systems? So according to the global government and leading companies, they are released some ethical guidelines in the designing of an AI system, such as the Australia's. So it have some regulation on the such as the human-centered values and should be considered the fairness, privacy, and also some transparency and explainability, and so on. So as an important branch of AI systems, in the designing of recommender systems should also consider these ethical challenges. So this named as responsible recommendations, or can refer as the trustworthy recommendation. So here got some limited research on this topic and give some definitions on this to meet the fairness, explainability, privacy, and so on, and these challenges. So at this stage, I start a literature review and to review this state of the art of responsible recommender system. So yes, and this paper is still on the internal review. So why responsible recommendation is vital? Because due to the public news and most people concerned about their private information, and also concerned about the privacy leakage. So in the recent years, and many privacy leakage news has been released to the public and great lots of concerns. So like the spread of misinformation and also doubt about the explainable result also should to the public concerns. So to hear why I would choose the graph learning for recommendations. There are two reasons. One reason is the data of real-world scenarios, often with graph structure. And second is the graph machine learning techniques are powerful tools to deal with the complex relations between items and users. So here is a simple example of the graph learning-based recommender system. As we can see, based on the users' relations and interaction, and we can build social relation graph. And we can left the right side based on the items, attributes, and we can also build a domain knowledge graph based on their different attributes and also the common attributes. And combine these two graphs, and we can further develop a user item interaction graph. And based on the click history, such as for the user M, and based on the click history, we can make prediction about whether this person would like to choose the toy or not. And also based on the purchase history and rating history, we can also predict the user's rating on the purchased items. So to further generate the recommendation list or just recommendation items. So to achieve graph learning based on responsible recommendations, what are the challenges? So the first challenges should be the privacy issues. So especially in commerce, and we often buy things online. So the system would collect our personal data and purchase history, like our gender, like our age group. So as same as a social platform, we can even share the our healthy details on the WeChat, like Facebook. So to protect privacy is vital. And here also got famous, the Europe GDPR regulation also set some strict rules on the data protection. So here got some research about privacy recommendations. While this Meng et al. also proposed a framework to protect user privacy against untrusted recommender and friends, and also some others also use the used to try to make the balance, to balance the trade-off between privacy budget and the accuracy of the recommendation model, and also Xing also use the metric factorization and combine with the differential privacy to protect users' privacy and also address the high dimensionality issues. So here, the open issues should be the robustness under different privacy settings, which can cause imbalanced data because for different users, they can select different privacy settings or high privacy or not sensitive privacy setting. And second is the security against malicious recommendations. As we know, there are some recommender systems can generate the media rich results like video, like image, and some of them might, such as for a young age people like under 18s, maybe this contains some adult content, so it might be not suitable for the kids or the elders. So this is the second open. Thank you. And to build users' trust, the successful ways to achieve transparent recommendation mechanism. So one direct and efficient way is to provide explainable results. So which calls the inspired by the explainable AI, and some mention also be proposed. And as we can know, most of the recommender systems are with black box settings, so the end users doesn't know the recommendation mechanism. So here got some research about explainable recommendations. Well, yes, here got a survey paper by Zhang et al. And this paper is published on the 2019. So, but in recent years, especially in recent 3 years, there got many new work has been developed, and such as propose the factorization models and propose the explainable matrix, and also use topic modeling to take the aspect importance of users towards the item, and also knowledge graph has been well developed to provide to generate the explainable results. So the open issues should be the aggregation of different explanations, such as in a knowledge graph and for a user, and it's the relation of the item like purchase history. So some of the paths between the users and the neighbors, the items can be taken as the explanations to the prediction results. So how to select the best combination of explanations is still challenging things. And second is that yes, context-aware explanation, because due to the human natures, we can choose our preference could be changed over the time by anything. So how to develop the model suitable for the dynamic, to generate the dynamic explanations is challenging things. So here got a simple example. As we can see on the right side, and from the SM digital library, you can generate the recommendation list. When I click the info button, it can just remind he used the CF and also topic modeling techniques. This is the kind of explainable recommendation website. So responsible recommendation should be privacy preserving and sample efficient, also explainable. And also we should also consider the fairness to debiasing and eliminate the discrimination, and also accountable. So to which person, to which group should this system be responsible to? So due to to address these items, I divide my task into 3 tasks. And the first task is about privacy preserving spatial-temporal POI recommendation. So in POI recommendation area, open challenges include robustness under different privacy settings. And second is efficient spatial-temporal graph model training. So AIM's task is to design and develop a graph embedding-based recommendation model for spatial-temporal POI recommendation to address efficiency and data imbalance challenge. So the proposed method is to use graph embedding-based recommendation model with federated learning settings and with verifiable method to accelerate training process. And here's a simple example. So it's a federated recommendation system. This in under federated learning settings, it allows the model like the recommendation model training on the local dataset, but not share their local dataset to the central server or the other client, and only pass gradient, and the central server can use like fed arranging method to update the gradient to further update the local model. And second task is about sample efficient federated graph learning model training. So the challenge should be the data sparsity, and second is the impact of missing attributes. So aim of this task is to develop a new federated graph learning framework by integrating meta-learning techniques in the model training process to address sample efficiency, and I consider the completion of missing attribute to enhance the prediction result by distribute matching method. I also considered about the the fit stage, one of the famous work, and the like missing attribute generator part. I believe some of you may be interested in that work. And the proposed solutions is to integrate the meta-learning techniques into the graph-based recommendation model and propose a novel graph meta-learning framework. And here, the researcher also defines the graph meta-learning into problems into three categories. And one is under single graph and use meta-learning to learn disjoint labels. And second is under multiple graphs and to learn the shared labels. And third is among multiple graphs and to use meta-learning to learn disjoint labels. And task 3 is about explainable federated graph learning for social recommendation. So the challenges would be like I said, aggregation of the explanations. So aim of this task is to design and develop an explainable graph learning based framework for the proposed social recommendation model and figure out the optimal metrics for evaluating the combining explanations, because actually in the explainable recommendation, and there indeed lack high quality metrics for evaluating the combined explanations. So the proposed solutions is to just design an explainable framework and based on the knowledge graph embedding techniques to generate the explainable social recommendation results. So here got an example from the knowledge-based explanation in image recognition task use semantic restrictions. As we can see on the top image, and from their model, they can use the text, some words to illustrate the graph, the image, top image, like a chef and his cooking and color, and on the upper image, they can generate some semantic text to explain the interior of a building. So here got actually in the first task, the dataset I used is the Foursquare check-in data, but I'm not choosing use the friendship relations. So, but in Foursquare check-in data, there has. So yes. And the second candidate dataset is the Yelp social data. It's public for academic use. So it's just similar to the Foursquare data. It contains POIs, users info, and also the check-in time and longitude, latitude. And yes, so thank you.